Okay, so we're into section 3, chapter 2. And there are a lot of problems in this section. So it's an important section. Since we skipped most of section 3 in chapter 1, we're going to make up for it here. So we're going to do all of problems 1 through 6 because they're matching. So we either do 0 or 6. So we're going to do 6. So match each term in group 1 with the appropriate description A through F in group 2. Assume that A and B are sets. So the intersection of A and B. So let's look at the choices. The intersection of A and B is ones that have common elements. If you have two sets and they have elements in the set, and there's some elements from set A that are also in set B. So let's look for the word common. And if you look through there, you'll see that the second entry says the set of elements common to both A and B. So that sounds like the right answer to me. And it is the right answer. So for number 1, B is the match. Okay. The union of A and B. Well, the union includes all the terms in A and all the terms in B, and there's going to be, there possibly could be some common ones, or there could be some that are not common. You could be completely independent. So it's going to be basically the set of all, the union of those two will include all of the elements of A and all the elements of B. So let's look at the answers. The set of elements in A that are not in B. Well, that's like a complement or something like that, so that's not it. So we already have B. The set of elements in the universal set that are not in A. Okay, so does it say both? B, the set of elements in B that are not in A. No. The set of the ordered pair, well, ordered pair has nothing to do with the union, so let's look at F. The set of elements that are in B or in A or in both A and B. So you can see we're using the or. Union is kind of like an or statement. So 2 will be F. 3, the difference of A and B. So let's just move on to the next one. Sometimes because that one's kind of a more complicated one. So the complement of A is the ones that are not in A, but they're also what are in the universal set. So if you looked at A, the set of elements in A that are not in B, but the complement really is not that. It's ones that are not in A but are in the universal set. So if you look at C, you can see that's what they say. The set of elements in the universal set that are not in A. So the complement is everything that's in the universal set that's not in A. Okay, so that's going to be C. Okay, 5. The Cartesian product of A and B. So let's just go back and remember what Cartesian product. Where are we here? Cartesian, okay. It's defined as so you ended with ordered pairs for one thing when you do a Cartesian product. So that's probably the easiest way to figure that one out. Has anyone mentioned pairs? So E mentions pairs. A set of ordered pairs such each first element from A and the second element B with every element of A paired with every element of B. So it's going to be E. Number 6, the difference of A and B. What do we have left? So let's think about this. We haven't used A, and we haven't used B, C, D. So let's just compare those two. The set of elements in A that are not in B, or it would be D, the set of elements in B that are not in A. So it's kind of the, yeah. Oh, okay, there we go. So one's the difference of A and B, one's the difference of B and A. So let's just go back and look at differences. So the difference of sets A and B, this is on page 59, the difference of sets A and B, written A minus B, is the set of all the elements belonging to set A, not in set B. Okay. So let's look at C and see what's left. A. The set of elements that are in A and not in B. So that's the difference of A and B. Differences of A and B. So it would be A. And the other one is the opposite one, so this is going to be D. Okay, so there you go. You see a little logic here. Sometimes, you don't have to find one exactly. You can kind of do the ones that are easier, and then you can find the ones that are more difficult. And there's nothing wrong with doing that. It's sort of a way of problem solving. Okay, so we're going to continue on. Now we're going to do every third problem. So problem number 7. So perform the indicated operations and designate each answer using the listing method. So the listing method is that you list all the intersection, what is the set of these various operations. So problem number 7 says X intersecting with Y. And we know it's intersecting because the other option is the union, and union looks like a U, so the other one, an intersection is the opposite of union. Not exactly the opposite, it's different. So let's look at, X, set X is a C. Actually, what I'm going to do is I'm going to add a page here, and then we can look back at these particular sets. So the universal set, which I guess includes everything, all the options, which are the letters A, B, C, D, E, F, G. So that's the universal set. And then we have subsets X, which includes elements that are in the universal set, but not every term. And Y is also a subset, and so we draw the elements from the universal set. And likewise with Z, we have B, C, D, E, F, so we have everything in the middle. So these are the first 3, these are like odd 1, 3, 5, 7, these are the middle ones. Okay, so what we're doing is the union of the intersection of Y and X and Y, so we're looking for the common terms. So A is common and C is common, and therefore the union of these two is the set which contains 2 elements, A and C. Okay, number 10. We have Y intersect with Z. So here's Y, A, B, C. Z has B, C, D, E, F. So the common terms are B and C. Okay, 13. X prime. Well, that means the complement. So it's what X prime is, what's in the universal set, but not in X. So we have A, C, E, F, A, C, E, G. So D, B, D, F are the ones that are not in X, but are in the universal set. So we're going to take B, D, F is the complement. Okay, 16. Complement of X intersecting with Z. Well, we have the complement of X, and we have Z, so we're going to look for terms. We've got D, B, D, and F. B, D, and F, and this is the intersection. So it's going to be B, D, and F, because that's the complement. And then we take the intersection of this one. Okay, 19 is we take Y intersected with Z prime, which is the complement of Z, and then we take that union with X. So before we do this part, we have to find out what Z prime is. And Z was B, C, D, E, and F, and therefore Z prime is A and G. It's the ones that are in universal set, but not in Z. And we already know Y. Y was equal to A, B, C. So when we take the union of, actually it's the intersection, sorry, the intersection of Y and Z prime, that is equal to just A, because A is the only common term. That's what intersection means. So we have A by itself. And then we take that union with X. So X is the set A, C, E, G. So when we take the union of this with that, or the union of this with that, well, you take all terms that are, all the terms. Well, we have A twice, so we don't need to repeat that. So we have Y union Z prime, pardon me, intersection union of X is the set. Well, we have A common, so we can just put A there, and we have C, E, and G. So it turns out that this whole thing is really just the set X. Okay, so we're going to stop that one, and we'll continue on the next recording.